We have finally made it to the end of our Six Sigma and Lean Six Sigma Green Belt course, which is based on the Council for Six Sigma Certification's body of knowledge. If you have not done so already, you should download a copy of the Council's Green Belt Training Manual, which covers the 12th through 24th chapters of their complete study guide. The prerequisite White Belt and Yellow Belt training courses cover the first 11 chapters. The training manual can be downloaded from the course description section for this course for free. But before attempting the 120-question Green Belt Certification exam, we should take some time to review what you have learned so far in this training course. Because you will only have 3 chances to pass the exam with a score of 70% or greater in order to receive your dual Six Sigma and Lean Six Sigma Green Belt certificates. This review will take about 5.5 hours to complete and has been split into 3 parts, after which you can take the timed exam whenever it is convenient for you. The Green Belt Certification exam is 120 questions. To pass, you will need to score a 70% or greater. There are 61 Green Belt, 44 Yellow Belt, and 15 White Belt question banks used in the exam, and 1 question is randomly pulled from each of these banks. The first 5 questions will cover Module 1, 7 questions will cover Module 2, 3 questions will cover Module 3, 6 questions will cover Module 4, 5 questions will cover Module 5, 4 questions will cover Module 6, 7 questions will cover Module 7, 4 questions will cover Module 8, 3 questions will cover Module 9, 4 questions will cover Module 10, and 10 questions will cover Module 11. Then we will have 5 questions from Module 12, the Define phase, 4 questions from Module 13, the Measure phase, another 5 questions covering Module 14, the Analyze phase, followed by 6 questions from Module 15, where we cover the Improve phase. These will then be followed by another 7 questions from Module 16, where we discussed the Control phase, 4 questions covering Intermediate Graphical Analysis, which was covered in Module 17, followed by 5 questions from Module 18, where we discussed normal probability distributions. Then we will have another 4 questions covering Module 19 on correlation and regression testing. We will have 5 more questions on non-normal probability distributions, which we discussed in depth in Module 20, followed by 5 questions covering Module 21 on hypothesis testing, another 5 questions on sample size, which was discussed in Module 22, followed by 3 questions covering Module 23, where we discussed advanced control charts. The final 4 questions in the exam will cover Module 24, which covered the application of statistics in business presentations. You may not take your exam while we are reviewing the information that will be on the exam. Once we have finished our review, then you may go ahead and take your exam. The system will automatically timestamp the start and submission times for your exam, and any exam that is stamped as having been started while we are reviewing this information will be flagged for cheating and your results may be invalidated. This review will take more than 5 hours to complete, and you will only have 3 hours to complete your exam. Any unanswered questions will be marked as incorrect. So even if you did cheat, your maximum possible score would only be 60%, which would be a failing score. Six Sigma teams enter the project process with various levels of information. Sometimes, a problem is fairly well defined before the team begins work, particularly in organizations that use a Six Sigma Leadership Council to choose projects and create teams. Other times, teams begin work with little information except that a problem of some type exists because the outcomes of a process are not as expected. Teams might not know where errors are occurring, or even begin a project with a complete understanding of the inputs and outputs associated with that process. Whatever knowledge teams begin with, the define phase is when teams move from very basic information about a process or problem to the knowledge and organization necessary to enter, measure, and subsequent other phases within a successful foundation. In the define phase, teams set rules, create a charter that will govern efforts moving forward, identify stakeholders and customers, define a process through process mapping, and of course prepare for a defined tollgate before entering into the measure phase. A project charter, or team charter, is a short document that includes information about the team and what they plan to accomplish. The purpose of the charter is to set expectations that can be agreed upon by the team, as well as the sponsor or executive leaders. Keep the team focused on the goal, ensure the project remains aligned with the goals of the business, and documents the fact that a control of a process is being moved from a business executive or manager to a Six Sigma project team. Minimally, team charters should include a complete and concise problem statement, a list of critical to quality metrics, or those measurements that will ultimately determine the project or process success, the names and roles of each person on the team, a list of both internal and external process customers, the name of a sponsor and/or champion, a duration for the project. Teams might also include information such as a list of non-customer stakeholders, an estimated schedule for each phase of the project, scope definitions for the process or project, and financial drivers for the project. The information for the team charter usually cannot be gathered in a single brainstorming session. The charter is an outcome of the entire define phase, not a quick notation at the beginning. By taking time to properly consider all elements of a team charter, Six Sigma teams create a stronger foundation for the rest of their work. Businesses that are implementing Six Sigma organization-wide might consider creating or using a specific template for team charters. Templates streamline define phases and make it easy for leadership teams and other employees to understand critical process controls at a glance. While final team documentation is likely to be extensive, and even in the define phase, teams themselves might work with lengthy requirement documents, charters themselves should be as concise as possible. Some organizations distill charters to a single page, while others use multi-page documents. Before moving forward with any work, even defining a team charter, it is a good idea for Six Sigma teams to establish some basic rules and requirements for the team. The ground rules for a project should be maintained in writing and approved by all team members, but they don't have to be part of the official charter document. The reason for documenting the rules and having all team members approve them is because a single team member cannot later claim to be ignorant of the rules. At the same time, rule generation on a Six Sigma team should not be a completely democratic process. Some of the more common sense or critical rules can be provided by the black belt or team leader. For example, ground rules should cover basic topics such as who will attend each meeting and the fact that team members should hold certain information confidential. A black belt might simply state that team members should observe confidentiality and attendance rules, be on time to meetings, and respect each other. The team itself will likely vote on the frequency of meetings and when meetings should be scheduled. Seeking team member input ensures that all team members can actually commit to meeting time slots. For consistency, it is best to hold meetings on the same day and at the same time each week, but it is understandably difficult to keep such a schedule through the entire life of some projects. Black belts might also provide some tips and suggestions for how team members should participate during meetings, particularly during group brainstorming sessions. Black belts should also dictate the rules for creating an agenda and running a meeting according to that agenda, though they might delegate some of these functions, such as timekeeper and secretary. We have covered a number of defined tools, including the SIPOC diagram and the 5 whys. Process maps and value stream mapping are two advanced Six Sigma tools that are often used in the define phase. Some Six Sigma teams begin using run charts to start defining a baseline in the define phase. Stakeholder analysis is a quick way to identify how various people within an organization relate to a project and how the team should keep them informed. Begin the analysis with a grid drawn over an XY axis. The vertical axis represents the amount of power a person has in the organization. The horizontal axis represents the amount of interest a person has in the team's project. The in and out box method is a quick and easy method that helps team define project or process scope. Begin by drawing a large box on a whiteboard or flip chart. Provide markers and sticky notes for the team. Ask the team to write down elements of the process to be worked on, including resources, activities, and people. Each item should be written on a sticky note. Work together to create as complete of a list as possible, placing the sticky notes on the wall or table as you go. Make sure everyone on the team understands that there are no wrong answers, and the first phase of the exercise doesn't require discussion. By brainstorming items with little to no discussion, teams can capture more ideas, leading to a more accurate picture of what is in and out of scope. The is not matrix is another quick brainstorming tool teams can use to define scope. It can also be used to help define some of the information necessary to a problem statement. The matrix works by considering specific things about the process or project and coming up with both is and is not answers. By the time the define phase is complete, the team should have identified and defined the scope, goals, and expectations of the project. The Tollgate checklist includes all of the mandatory steps to ensuring you have completed the phase, such as the creation of a comprehensive project statement, the development of a team charter, and understanding of the process being improved, as well as the voice of the customer, and a definition of what success will look like. In order to create a strong problem statement, there are some basic pieces of information that we will need to include within the statement itself. We need to declare where and when the problem was recorded or was occurring, what the measurement of magnitude for the problem was, preferably with some tied to cost, and a brief description of the problem that could be understood by professionals not closely aligned with the process. A project charter or team charter is a short document that includes information about the team and what they plan to accomplish. A thorough understanding of the process starts with the creation of a SIPOC diagram to define the suppliers, inputs, process, outputs, and customers. From there, we need a value stream map to visually show how inputs move from the suppliers through the process and onto the customers, as these two will define the boundaries of the process and identify the resources needed to complete the process. In order to understand the voice of the customer, you need to understand what the actual needs of the customer are, and this should be based on data collected from the customer, not just assumptions made by management. We must define what success looks like, but this definition should be based on the critical to quality data. It should be measurable. It should be a metric that can be compared both before and after project completion. The team and the project sponsor need to agree on what will define success for the project, and everything should be documented. Moving from the define phase to the measure phase of a project, Six Sigma teams continue to delve into the process, now coming to understand processes more fully through data. The measurement phase is often the most laborious phase for the team, especially when data is not readily available in digital formats. One of the first steps of the measure phase is determining the capability of a process. This step can be completed before a team formally leaves the define phase if the data needed to perform sigma level calculations is available. In addition to sigma levels, teams might also calculate various metrics for a process, including defects per million opportunities, first time yield, or rolled throughput yield. The failure modes and effect analysis is a tool that can be applied by a Six Sigma team in any phase from define to analyze. Often, teams begin working with the failure modes and effect analysis in measure because it helps them identify risk priorities for various inputs and errors within a process. When used properly, the failure modes in effect analysis uses systematic data and team input to set the stage for root cause analysis in the next DMAC phase. Remember, while toll gates do occur and teams move through 5 phases during a DMAC project, hard borders don't always exist between phases. Teams might begin working on measure phase tasks before leaving the define phase, and it is almost certain that the team will begin some form of analysis while still collecting data. Ultimately, a failure modes and effect analysis tool should be used when teams need more detailed information about inputs and possible associated fail points than the tools discussed previously. The failure modes and effect analysis offers some of the information that is also offered by the SIPOC diagram, but it also provides evaluations of the inputs. Teams typically create failure modes and effect analysis in a spreadsheet program, as some calculations are required during the process. A FMEA, or failure modes and effect analysis, generally includes the following information: the process, the potential failure point, the potential failure effect, a severity rank, the potential cause of the failure, an occurrence rank, the current monitor or controlled method, the detection rank, the risk priority number, any recommended changes or actions, who is responsible for the changes, and when they will be accomplished, the action completed, and the recalculated severity and detection ranks, as well as a new risk priority number, after changes have been implemented, of course. During analyze and improve phases, the teams would recommend changes, implement the recommended actions, and rescore the process to determine if the RPN of the change process is lower. If it is higher or the same, then the change was not a good one and the team might need to try again. Creating a baseline metric for a process begins in the define phase, but teams cannot leave the measure phase without a strong understanding of current process performance. That understanding begins with figures such as sigma level, but teams should also define a process-specific metric where possible and gather historical data regarding that metric so that they have something to compare future data against in order to prove that improvements were made. Ideally, the team would have access to historical metrics for the process. In some cases, however, the team has to collect data from scratch. Before creating and displaying a baseline metric via graphical representation, you have to understand the type of data you are dealing with. Data is either discrete or continuous, and teams collect data either as a population sample or as a process sample. How teams collect data and the type of data collected determine how the data can be viewed graphically and analyzed. Discrete data is categorical in nature. It is also referred to as qualitative data or attribute data. Discrete data falls into 3 categories: ordinal, nominal, and binary, or attribute data. Data sometimes collected can be expressed in one or more of the discrete categories. For example, student test scores can be conveyed in an ordinal fashion via the grades A, B, C, D, and F, or in a binary fashion via the pass-fail distinction. Continuous data is quantitative data and is measured in units. For example, the time of day is measured in hours, temperature is measured in degrees, and almost anything can be converted to continuous data by making it a percentage of the whole. Sometimes a process or activity can be measured in both discrete or continuous data. Depending on the purpose of the measurements, teams might need to pick between the 2 types of data. Data can be classified at 4 basic levels: nominal, ordinal, interval, and ratio. Attribute or binary data is actually a limited form of nominal data. By the time the measure phase is complete, the team should have agreed upon the key measurements and come up with a baseline measurement of process performance. Analyze the measurement systems and identified any issues that might contribute to analysis error. Corrected the measurement system and remove any error risk. Calculated process variation and sigma level. Conducted an appropriate sampling to allow for a statistically valid conclusion, and the sponsor or champion should have signed off on all elements. The team and its sponsor should have come up to an agreement on key measurements. By the end of the measurement phase, before we collect the data, we need to ensure that the data is accurate. And we can do this only by first analyzing the measurement system for variations to ensure that the measurements are always accurate and precise. In the event that we found any issue or errors with the measurement system, we need to correct them. We need to ensure that we are using the correct gauge, that we took into consideration the 10-bucket rule. While most of the calculations will be dealt with in the analyze phase, there are some things that need to be determined by the end of the measurement phase. We will need to calculate the variation in the process and the sigma level in preparation for the analyze phase. The measurement phase is where we collect the data needed for the analyze phase. So, in order to complete this phase, we need to have already conducted a large enough sampling that will allow us to draw valid conclusions about the population. Before you can begin the analyze phase, you also need to finish the measurement phase, and that requires an approval from leadership. That means you will need to have the project champion or sponsor sign off. You will have to present the status of the project to the sponsor or champion, which means the data must be compiled and reviewed for any issues. The measure phase is especially long because the phase requires a great deal of work. Without a strong measure phase, the team cannot move on to analyze the data and make data-based decisions that drive improve and control phases. Analyze phases also require a lot of work, but that work is usually performed by black belts and green belts, who report findings to Six Sigma team and ask for feedback about analysis and verification of that analysis. One of the fundamental activities of the analyze phase, performed by the entire team with the help of identified subject matter experts, is the root cause analysis. Root cause analysis is used to identify root causes for problems or defects when a team has reached the analyze phase without a clear idea of primary causation. Some of the tools described for identifying root causes could be used in either the define or measure phases at the discretion of the black belt leading the team. The failure mode and effect analysis could likewise be used in the analyze phase as part of root cause analysis. Popular methods for brainstorming and analyzing causation in a process is the fishbone diagram. The fishbone diagram, or Ishikawa diagram, can be completed by a single Six Sigma expert, but it typically has more value when it is completed by the entire Six Sigma team. The diagram lets teams concentrate on brainstorming processes that generate ideas about possible problem causes, organizes those possibilities in a logical way, and lets teams visualize the information to identify priorities, trends, and relationships between ideas. When used as a team activity, the fishbone diagram encourages participation and input from all team members, which increases the chance of laying the foundational work for a viable and original solution. Once teams identify possible root causes, they must verify that the causes are valid. Root cause verification can be completed via a variety of methods, including statistical analysis, design of experiments, logical questioning, observing a process, gathering additional data, analyzing data via graphical representation, and mapping processes at a more granular level than accomplished in the define phase. Whatever method is used to validate root cause assumptions, the Six Sigma team should document it. Documentation regarding root cause verification is usually completed on a matrix that includes the problem, possible root causes, the verification method, why the verification method was chosen, results of the verification, and in some cases, whether a senior Six Sigma leader such as a master black belt agrees with the consensus. Six Sigma experts and teams can use a variety of graphical analysis tools to help generate ideas about root causes, or understand how inputs and outputs really impact each other. Some of those graphical analysis tools require statistical analysis software. The first graphical tool for validating root causes is the Pareto chart. The Pareto principle, or 80-20 rule, states that 20% of the causes lead to 80% of the results. Because of this, a Pareto chart is a good starting point for root cause brainstorming. Teams can start with just a few inputs or attributes accounting for the bulk of the Pareto chart. Just as you can drill down using the fishbone diagram, asking deeper and deeper why questions, you can drill down using a Pareto chart. Box plots, which are often called box and whisker graphs, are another graphical representation that can be handled with Excel. When differences between distributions are marked, however, or when outlines are fairly obvious within the data, the image of a box plot tells its own story without requiring advanced statistical knowledge. Hypothesis testing lets Six Sigma experts draw conclusions about the population based on a statistical analysis performed on the sample. Because the conclusions are based on samples and not the entire population, there is always some risk of error. You might have seen or heard poll results given with a plus or minus in the result. 60% plus or minus 2 percentage points would vote for the candidate today. That plus or minus is the value of the error risk. In statistical analysis, the risk that a sample doesn't offer a good representation of the population is known as the alpha risk and the beta risk. Using information about the sample and alpha and beta risks, statisticians calculate what is called the p-value. The p-value is a probability estimate that tells statisticians how likely an assumption or conclusion drawn on a sample will be incorrect. Statistical software removes a lot of the manual calculations from the process of setting up and running hypothesis tests. With Minitab, for example, Six Sigma experts can conduct hypothesis tests on prepared data with only a few clicks of a mouse. They do have to know which type of tests to use and in what situations. Regression and correlation analysis helps Six Sigma experts understand how variables within a process might be related. Regression analysis helps teams define the relationship between one independent variable, possibly an input, and one dependent variable, possibly an output. Correlation and regression analysis doesn't always provide the information a team needs to determine relationships between variables, especially when those relationships are complex or multiple variables are present. Because the analyze phase sets the stage for the improve phase, teams have to be as certain as possible in their analytical conclusions before they decide on a solution for implementation. A design of experiments can provide the most granular details and analysis required for that level of certainty. Before Six Sigma teams can move on to the improve phase, a Tollgate review is conducted. To complete the phase, you must have ensured that all primary root causes have been identified and that the team has prioritized them. You will need to make sure that any assumptions regarding the root causes are backed by statistical data and that the relationship between all of the variables are fully understood and confirmed statistically. After all of this has been completed, it is time to meet with the project champion or sponsor and provide them with your findings. Once they agree, then they will sign off on the phase and you are free to move on to the implementation phase of the DMAC process. In identifying the primary root causes, you most likely used a fishbone diagram and have found that there are many different causes. So, you need to narrow down that list. While it is a rarity that you will find only a single root cause to a problem, this does happen from time to time. In most projects, however, we will find many different causes, and so we need to prioritize them based on impact to the process and even their impact to other processes. Before you can begin the improve phase, you need to finish the analyze phase, and that requires an approval from leadership. That means you will have to have the project champion or sponsor sign off. You will have to present the status of the project to the sponsor or champion which means that root causes need to have been identified and narrowed down to the vital few, and that you can explain the reasons behind the prioritization chosen. Remember that in Six Sigma we need to back up all assumptions with statistics, so you need to be methodical and find concrete cause and effects evidence for root causes. Remember, you should not ignore the importance of treating symptoms for short-term relief, while at the same time, you should focus on correcting and remedying the root causes rather than just the symptoms. You should have conducted a correlation and regression analysis to ensure that you understand the relationship between the variables within the process, and always remember that you need to verify everything with statistics. During the improve phase of a DMAC project, Six Sigma teams brainstorm possible solutions for root causes identified in the analyze phase and rank those solutions according to cost, how effective the solution would be, and how likely the solution could be implemented. Analytical rankings are used to prioritize and select solutions for implementation. Teams pilot solutions through beta tests or small rollouts and collect data on the solution so that they can verify that the solution is working as expected via statistical analysis. Once the team is confident that the solution works to address the problem, it plans and implements a full rollout of the solution. A solution selection matrix is an analytical tool that lets teams propose and rank solutions for any of the root causes identified in the analyze phase. While teams can work simultaneously on multiple solutions if multiple prioritized root causes were found, Black Belt and other team leaders must remain cognizant of timelines, resources, scope, and the purpose of the project. If a single solution provides enough positive impact to reach project goals, then other solutions might be saved for future improvement projects. If one solution would reach results, but another solution would be especially easy to implement and provide additional positive results, the team is likely to decide to implement both. A solution selection matrix can be created in Excel, and teams should work on the document together in a brainstorming capacity. It is a good idea to include the entire team, as well as relevant subject matter experts and stakeholders during the solutions brainstorming. This ensures that the solutions the team comes up with are more likely to be a realistic fit for the process and business. Once solutions are selected using the matrix, teams will also likely have to get sponsor, champion, or leadership council support before a partial or full implementation is possible. This is especially true where solutions require expenditures or will impact processes and people outside of the project scope. When teams include the appropriate individuals in the process, a solution selection matrix is very adept at identifying the best possible solutions for implementation. Leadership councils and executive sponsors often want more information about the costs and benefits expected for a solution. So teams should be prepared to create a cost-benefit analysis. Black belts often have many of the elements required for such an analysis after the measure and analyze phases. But teams might also need to work with accounting, finance, or business planning departments to gain accurate financial details required. The goal of a cost-benefit analysis is to compare the costs of implementing a solution with the monetary benefits expected from the solution. Costs include expenses such as software development or purchase, equipment purchase, building development or renovation, additional labor or hiring, training expenses, additional supplies, and any losses associated with disruption as the solution is being implemented. Benefits might include an increase in product margin, increase in revenue, cost savings or avoidance, and intangible benefits such as an increase to staff morale or customer retention. Six Sigma teams usually aren't in a position to handle detailed cost-benefit analysis such as might be completed by a certified account, but they can create an idea of cost-benefit relationships via the payback method of analysis. This is the simplest way to approach such an analysis and provides leaders with an estimated time before a project pays off. To conduct a payback analysis, Six Sigma teams must have an estimated cost for the project as well as the estimated financial benefit per year. Remember, financial benefits don't just include increases in revenue. Cost savings, new customers, or mitigation of customer loss can all be considered as contributing to benefits each year. A more concise way of calculating cost benefit is known as the net present value or NPV. The net present value adjusts benefits and costs as time passes because cash flow in the future is not as valuable as cash flow currently due to inflation and other economic factors. Once a solution is selected and work done to bring it into production at a minimal level, the Six Sigma team is ready for a pilot. A pilot is a limited trial of a solution in a live environment. No matter how much analysis was completed or how well test cases were ran, teams cannot know for certain how a solution will behave in a real-world scenario. The live production environment will always have variables that teams cannot account for, particularly when people are involved in the process. The benefits of a limited pilot include a limited use of resources, which reduces waste if the solution turns out to be incorrect or not effective in resolving the problem. A confirmation that the expected results occur. It allows troubleshooting of a new solution on a smaller scale to minimize disruption during a full transition. And it lets employees outside of the Six Sigma team provide feedback on the solution and implementation to make the final rollout more successful. Teams do not have to pilot every change they made. Simple or small changes can be made without piloting as long as the team documents the changes well and measures results for verification. When changes are large in scope, could cause expensive or expansive consequences, or would be difficult to reverse, teams should begin with a pilot. The same is true for any solution that might be expensive to implement at a full scale. Pilots can occur on a limited scale or for a limited time. Limited scale pilots incorporate a specific region, team, group of people, or machinery. Limited time pilots implement a temporary change. At the end of the scheduled time, the team makes a decision about whether the change should be permanent. Pilots can occur with either processes or products. Process pilots might feature testing specific locations, testing results with some customers, working with some employees to test new processes, or conducting dry runs of a process without impact to the end user. Product pilots are conducted using test markets, product models, or alpha and beta testing of the product with certain end users. Once solutions have been verified through tests and analysis, teams can begin the work of implementing changes on a large scale. Teams should create and work from an action plan during this vital and active stage of the DMAC process to ensure that no plans or requirements fall through the cracks. During the active part of the improve phase, the project leader will likely delegate numerous activities to members of the team, and the team will also rely on input and assistance from those outside of the Six Sigma team. Keeping an action plan document helps everyone on the team see where they are in the process, what they are responsible for, and what date work must be completed by. If the Six Sigma team is working with a project manager, he or she is likely responsible for action plan documentation and follow-up. Teams can also use a basic spreadsheet or Word document, which should be saved in a common location to keep track of what work is to be done and who will do it. Because every project is unique, improved action plans are also unique. Most action plans will contain common tasks such as documentation, training, and transition. The Six Sigma team should have documented all of its work so far in the DMAC process. If asked, the black belt or designated team member should be able to present the analysis in the form of data tables, statistical calculations, and explanations and graphical analysis. Six Sigma teams usually aren't in charge of complete staff training on any improvement they make. Instead, teams begin the training process by working with training subject matter experts or delegates in the department impacted by the upcoming changes. During the improve phase of a DMAC project, teams should begin to consider the need to transition a process back to the business and traditional process owner. Transition is part of the control phase, but teams should move from improve to control with a good understanding of how the process should be measured and monitored. Strong documentation and training during the improve phase helps cement the success of the control phase. Before moving on to the control phase, a Tollgate review is conducted. During the phase, we need to make sure that solutions were reviewed and prioritized, and that only one or two top solutions were selected for action. That we first implemented these solutions on a limited basis in order to reduce the risks associated with their implementation. The data from limited trials was analyzed, and solutions appear to work as expected. From there, a cost-benefit analysis was performed, and the team comes to an agreement to implement the solution in a live environment. The improvement and the findings were presented to the sponsor or champion, who then signed off on it. Everything gets fully documented and added to the standard operating procedures, and critical staff receive training on the solution and are prepared to pass that training on to others. The team brainstormed possible solutions to problems and created a solution selection matrix for each of the causes identified in the define phase. Based on these rankings and good old common sense, one or more solution are then selected and presented to leadership. Teams decide whether to pilot or beta test solutions. If the team determines that a beta test is needed, then they conduct a pilot test first and then conduct a beta test. The team also creates an action plan to ensure data is captured and measured properly before conducting the testing. Based on the action plan, the data collected from the pilot and/or beta is then organized and compared to the baseline data captured during the measure phase. Teams took the time to estimate the total cost of the project as well as its financial benefits of the improvement implementation and the cost of maintaining that implementation. That information was then presented to the sponsor or champion, which means that the prioritized solutions were identified, a cost-benefit analysis was conducted, the results from the pilot or beta test were prepared, and the information was presented to the sponsor or champion, who then has to sign off on the solution. As with everything in the Six Sigma initiative, everyone must agree on the improvement implementation.